For balancing complex redox reactions, this is where we don't have a simple metal or nonmetal, but we've got polyatomic ions involved. So it's a little bit more complicated. So what we want to start off with is just a skeleton equation. So we're just going to read the question, and it says chlorine, okay, chlorine is always Cl2, is converted to perchlorate. This is a polyatomic. If you look on your data book, you'll get ClO4 with a -1 charge. That's the formula for perchlorate ions. We also know it's in an acidic solution, which is good information because when we're balancing this, we're going to have to use hydrogen ions. Write the half reaction equation. Is this half reaction oxidation or reduction? So start with your skeleton equation. I'm beginning with Cl2, and eventually this is going to be converted to perchlorate, which is ClO4 minus. Chlorine is a gas. This is an ion in an acidic solution, so it's aqueous. Remember when we're doing these complex balancing, the AOHC method. A stands for all, so we balance all except hydrogen and oxygen. So the only other type of atom present here that isn't an O or an H is a chlorine. So on this side I have 2. On this side I only have 1. So I have to put a 2 in front of my perchlorate so I can balance the chlorines. Okay, we've done that step. Next step is balance the oxygens. In order to balance oxygens, we have to add waters to whichever side is lacking oxygen. On this side I have 4. On this side I have 0. So if I want 4 oxygens, each water contains 1. I need to have 4 H2Os. Actually, sorry, in this case we'd have 8 because the 2 times 4 gives us a total of 8 oxygens. So I would need a total of 8 waters over here since each water contains 1 oxygen. So now we finish this step. Next step is H, balance the hydrogens by using hydrogen ions. So on this side, I have 8 times 2 is 16 hydrogen. On this side, I have none. So I have to add 16 H plus, aqueous. It already told me it's in an acidic solution, so it makes sense that we have hydrogen ions. Last step is the C, which means charge. So now that we've balanced all atoms, oxygen atoms, hydrogen atoms, last step is balance the charge. The total charge on this side, the waters are a charge of 0, and the chlorine gas is a charge of 0. So the overall charge on the left side is 0. On this side, I have 2 times -2. So I've got -2 here with the perchlorate. And then I have 16 times +1. So I have +16 from the hydrogen. The overall net charge is going to be +14. How many electrons do we need now to... So the side that is higher in positive charge is where we're going to add the electrons. So 14 here, here I've only got 0. So to make both sides equal charge, I need to add 14 electrons to this side.